Alright, taking a look at Polynomial Functions 3.6. So, these first ones want you to factor special products. Okay, this is when the box method doesn't really work that well. There's a way you can get it to work, but it requires a lot more steps. There's some special, really easy ways to do it. And we've got 3 of them, and I've got them up here. You may want to write them down. There's one called the difference of squares. Okay, because you've got a squared minus b squared like number 1. 4x squared is really like 2x squared, and 25 is really like 5 squared. So that's why they call it the difference of squares. So all you do is you put it in that format. So I take 2x is like the a, so I go 2x plus 5 is like the b, times 2x minus 5. And it's factored. That's all we got to do. Okay, so if we look at number 2, same idea. It's really 3x squared minus 4y squared. So I go 3x plus 4y, and I go 3x minus 4y. Really, the toughest part about this is just remembering it and recognizing those difference in squares. So if we look at 3, we've got ax squared minus b squared. So it would be ax plus b times ax minus b. Okay? Just a quick, easy way that you can factor. Now, we're looking at, so we did those 3. Now we're looking at these 3, and these are what we call the sum and difference of cubes. Okay? Sum or difference of cubes. So we've got a cubed plus b cubed, and this is how we can factor it out. We've got a cubed minus b cubed, and this is how you factor it out. So we've got 1 plus, so let's look at 5 first. Now, 27x cubed. 27, what is that? Well, it's actually 3 cubed, so 3x cubed plus a is really 2 cubed. So knowing those cubes is really helpful in doing this. If you don't know those, you're just going to have to take a guess at what you might think it is and then use the calculator to double check. So 3x is like a here. So I put an a here, a squared here, a, and then b squared. So we'd go a plus, and then 2 is like the b. Oops, not a. 3x plus 2 for that beginning. And then I'd go 3x, the whole thing squared, minus 3x times 2 plus 2 squared. So then we can simplify this. So I get 3x plus 2. Well, 3 squared is really 9x squared, minus 3 times 2 is really 6x, plus 2 squared is really 4. Now, we could leave it that way, but we really need to double check to see if that one can be factored. Okay? So, we go 9 times 4 to get 36. And we've got 9x squared. We've got 4. And we need to see what factors of 36 add up to negative 6. Well, we've got 9 and 4 doesn't. So we got 1 and 36, definitely won't. 2 and 18, no. 3 and 12, no. And it may be that we can't factor this, but we've got to check. 4 and 9, and 6 and 6. So this doesn't have anything that we can factor further, so we would just leave it like that for us. You know, we could use the quadratic formula to see exactly what those factors would be to factor it further if we really wanted to, but we're not going to worry about that here. Okay, so now let's take a look at 4. So 64. 64 is actually 4 cubed, so it would be 4x cubed minus 125 is 5 cubed. I should probably put cubed, not squared. So this one, now we've got the difference of cubes. So I put the 4 in for all these a's, I put the 5 in for all the b's. So we'd have 4x minus 5 times 4x squared. The whole thing is squared, don't just square the x. Plus 4x times 5 plus 5 squared. So 4 squared is 16x squared plus 20x plus 25. And then we could try to factor that further if we really wanted to. We're not going to worry about that right now. We could graph this and find its roots, its zeros, x-intercepts, and that would be honestly the easiest way to do that if we really wanted to. So that's number 4. Now number 5 or 6, we do the same exact thing. So 1000 is like 10x cubed minus y cubed. So 10x minus y times 10x squared, which 10 squared is 100, so let's just write 100x squared plus 10xy, because they're multiplied together, plus y squared. And there we go. That's good enough for us right now. Okay? Alright. So now, 7, 8, and 9, it says find all zeros of each polynomial, then sketch the graph. Use technology to check your answer. Okay, so how are we going to figure out these zeros? Well, we can use that difference of squares here, because that's like x squared minus 5 squared. So it factors out to be x plus 5 times x minus 5. So if we want to find the zeros, the x-intercepts, we make that f of x 0, and then each one of these we're going to set equal to 0 separately. So minus 5 would give us negative 5 equals x. Add 5 to both sides to get 5 equals x. So we've got the zeros. Okay, then it wants us to sketch the graph. So let's get a graph here. So I've got a graph. So we graph at negative 5 and a positive 5. Okay. Now, it's a cubic, a quadratic, it's a quadratic, so we know it's a parabola, and it's positive. So it's an even positive, so we know the end behavior is going to be going up and going up. Okay. Now, we could figure out what the minimum is if we really wanted to. We could also figure out what the y-intercept is, which would be pretty easy, because if we made this x 0, we'd be left with negative 25. So we were going to go pretty far down, so we'd go like clear down to here. That would be like negative 25. Okay, that's where our y-intercept is. That's actually going to be our minimum, because the y-axis is exactly in between those two, and thinking about that symmetry, we know that's where it's going to be. So we draw our graph. And that second line wasn't very good. Something like that. And that end behavior just keeps going up and up. So there would be our graph. Okay. Alright. Now let's take a look at number 8. So we've got 4x squared, so that's like 2x squared minus 9, which is 3 squared. So we get, when we factor it out, we get 2x plus 3 and 2x minus 3. Okay. Oh, we could have used technology to check that. I could have did it on Desmos, but I knew I was right, so I didn't. You guys may want to double check your work. Okay, and Desmos is a great app to help you do that, or even the calculators in class if you got time. So, that's really equal to g of x, but if we want to find the zeros, find the x-intercepts, we make it 0. So we'd go 2x plus 3 equals 0, and 0 equals 2x minus 3. So then we solve. So we get 3 equals 2x, divide by 2. So I get 3 halves equals x, which for you guys, you like 1.5, okay, or 1.5. For this one, we'd subtract 3 and get negative 3 equals 2x, and divide by 2, so we get negative 3 halves, or negative 1.5. Okay. Once again, it's a quadratic. It's positive, so we know the end behavior is going to be going up this way and this way. So we plot our points: negative 1.5, positive 1.5. Okay. Now, if we want to find our minimum, notice we're the same distance again, so it's just going to be on that y-axis. So take our equation, put 0 in for x, and 0 squared times 4 is still 0, so we get negative 9. So drop down to negative 9, and there's our quadratic. Okay. Once again, that one's pretty simple. You don't really need technology to check that one, though I guess technically if you're watching this, you are using technology to check it, so it works either way. Okay, now let's take a look at that last one. Okay, number 9. So we've got x times x squared minus 5x plus 6. So we would set it equal to 0. What I should notice is that with this x multiplied by an x squared, we're dealing with a cubic here. Okay? It's positive, so end behavior of cubic on positive is going like that, right? The Egyptian. Okay? So we go up. As we go to the right, we go up. As we go to the left, we go down. So now I need to factor this further. Okay? So we can use the good old-fashioned box method. And get x squared and 6. Factors of 6 add up to negative 5. Well, that's going to have to be a positive 1x and a negative 6x. Right? No, that won't, because we need a double negative, don't we? Because it's a positive 6. So it'd have to be 2x to the negative and 3x to the negative. Because 6 would be negative 3 times negative 2. So pull out a negative 2, pull out a negative 3, pull out an x, pull out an x. So we really have x times x minus 2 times x minus 3. So that being able to factor is very important for this aspect of what we're doing and the next unit. So make sure you remember how to do that. Now we take each one of these and set them equal to 0 separately. Which you'll notice that first one, we didn't have to do anything. It was already solved. And we end up with zeros or x-intercepts at 0, 2, and 3. So at 0, at 2, and at 3. Okay? Now, because it's that cubic, we know the end behavior, so we find, when we're going to the right, you find your x-intercept furthest to the right, and we know from that one, we're going up. Okay? We also know from the furthest one left, we're going down, because that's our end behavior. So now, trying to figure out what's going on in the middle, okay, well, the easiest thing is to just, you can kind of take a guess at it. Something like that. So I'd probably start down here and go something cool like that. Okay, now this one we can check on Desmos. So let me get it typed up. And I can type it in exactly how it looks. Okay, zoom in a bit. And let me get it now. I'm taking a picture of it, essentially. And then I'll throw it up on the screen for you guys. We can see what it looks like. Okay, not too bad. We probably went a little too low on one of those dips, but pretty good. Alright. Okay, multiplying polynomials. This is just review. Remember, we've been kind of doing some of this. X times x is x squared. Well, first of all, look at this one. And then look at this. Okay? Notice we have the right side on all of these, so we can just use this instead of multiplying. I mean, I'll show you on the first one that it's going to work out. Okay? So that would be like A and B and A and B. So it's minus and plus, minus and plus. Remember, order doesn't matter. So if we did it FOIL way, we'd go x squared minus 3x plus 3x minus 9. Negative 3x, positive 3x gives us x squared minus 9. That's what we would get, right? if a is here, we just take a, square it, x squared. B is here, 3, take b, square it, 3 squared is 9, put a minus in between, and there you go. So it works, okay, but it's just easier to use a shortcut. So 11, a and b, so I go x squared minus, oh crap, this one won't work, will it? Because it's got a double plus there. There is another one for this, but this is just a perfect square trinomial. Okay, so it'd be x squared, then you'd be x times 4, so 4x, x times 4, so 4x, 4 times 4 is 16. So you end up with x squared plus 8x plus 16. Okay, this is what you call a perfect square trinomial, because that really, x plus 4 squared is the same as this, and it would equal, that's like, that a, so actually if I traded it to a plus b the way they did it, okay, you'd end up with a squared plus 2 times a times b plus b squared. 16 is 4 squared, x squared is x squared, 8x is 2 times 4 times x. So it fits that middle piece. So there is another special pattern there that you can use sometimes as well. Okay, now let's take a look at 12. Does 12 look like any of these? I believe it looks like that one. So a would be x, b would be negative 2. So you'd end up with x cubed minus 2 cubed, which is 8. If you want to, you can FOIL that out and double check, or you can just trust me. Probably should show you that it works, shouldn't I? Be all good teacher-ish and whatnot. X times x squared is x cubed. X times 2x is 2x squared. X times 4 is 4x. Negative 2 times x squared is negative 2x squared. Negative 2 times 2x is negative 4x. Negative 2 times 4 is negative 8. Notice positive 2x, negative 2x squared. Cancel out. Positive 4x, negative 4x. Cancel out. What are we left with? X cubed minus 8. Okay, so it works. So 13, we look like this one, right? The sum of cubes. So that's a, that's b, so I simply go x cubed plus 1 cubed, which is just 1. Because 1 times 1 times 1 gives us 1. So these are shortcuts in these certain situations that make life a lot easier. Okay, now let's take a look at this. So, factor x to the 6th minus y to the 6th as the difference of two squares. Then factor your answer as the difference of two cubes and sum of two cubes. So, what they're saying is, think of that as x to the what power squared minus y to the what power squared. Well, if you think about the rules with powers, right, with exponents, if I have x squared to the 3rd, we multiply those to get x to the 6th. So this would be x cubed and y cubed. Okay, so then using that special rule, right, over here, difference of squares, we make it x cubed plus y cubed times x cubed minus y cubed. Then they're saying, well look, that's just these other guys, right? So they want us to apply that. So the sum, we add them and then do that. So it would be the sum. So let's jump down here. The sum would be x plus y times x squared minus x times y plus y squared. And then we'd multiply this one, and that would be x minus y, right? Yep, and then these are both plus. So then x squared plus xy plus y squared. Okay? So this was for the first part, and then this part. Okay? Then, I guess you could say, could we do anything else with that? Probably not. Okay, though yeah, that's pretty much it. So then it says factor this as a difference of two cubes. So that means it would be x squared cubed minus y squared cubed. So it would look like this one. So we'd go x squared minus y squared times x squared plus x, oh, hold on. That would be x to the fourth, wouldn't it? Because it's x squared squared, right? It's x squared squared minus x squared y squared, oh, plus y to the fourth. Okay. Then they say, then factor our answer. So we'd need to, we could factor that out, couldn't we? That would be the difference, so that would be x plus y times x minus y, because that's back to the difference of squares. This one, can we factor that out? Okay. So, you know, kind of looking at that box method, I guess. We'd have x to the fourth, y to the fourth, x squared, y squared. I don't think this is going to work the way I thought it might have. No, we'd probably have to go x times y, x times y. No, that wouldn't work either. Guess the box method won't work for us when we're just dealing with those. Or at least I don't know how to make it work. Okay, should you ultimately get the same answers? Probably. Did we? Okay, I'm not, to me it's not looking like it's going to end up being the same, right? This part is the same. We've got that part the same, right? Okay, so would this turn into this if we multiplied? Guess that's the question. Can we get this to turn into that one? Okay, so x times x will give us x to the fourth. Okay, x times xy would give us plus x cubed y. X squared times y squared would give us x squared y squared. Okay, plus, now we multiply this one. Negative x times x would give us a negative x cubed times y. Plus negative x times that would give us a negative x squared y squared. Okay, plus that would give us a negative x y cubed. Okay, so that was multiplied by all those three. So now this y squared times x squared will give us plus y squared x squared plus y squared xy would give us x y cubed plus y squared times y squared would give us y to the fourth. So now we got to hunt and find stuff that's the same and see if they eliminate. Well, x to the fourth stays, y to the fourth stays, okay, which is similar to those two. So we just need to see, do we have that left over? Well, x cubed y, we've got a negative x cubed y, so those would cancel, positive and negative. We've got x squared y squared, negative x squared y squared, those two would cancel. Negative x y cubed, positive x y cubed, those would cancel. And then we're left with that, plus a y squared x squared plus y squared. So yeah, do we get the same answers? Yes. Did we? Yes. So why would that be? Well, we're dealing with multiplication, and factoring and all that, you know, is basically multiplication. And does it matter which order we do multiplication? No. 2 times 3 times 6. If I multiply those two first or multiply those two first, we're still going to get the same answer. So it has to do with that. So, there you guys go.